Hello everyone. Welcome to my YouTube channel Trance. Today we're gonna solve an amazing question on inequalities. Okay, so this is the question which I solved when I was preparing for regional mathematical Olympiads. Okay, I hope you all are doing well. So let's get started. Okay, so can you find the maximum value of a where x1 is greater than x2 is greater than and so on till x2025 and the following inequality is given. Okay, so this is a very lovely question. If you would like to try it, do pause it and give it a try. So I hope that you might have given it a fair try and you're not able to solve it. Okay, it is a difficult question because it requires the application of Cauchy scores in a very advanced level. Okay, so I'm assuming you've given it a fair try, and so I'm moving on ahead with the question. So let's see what I can do. Okay, so all of these quantities are positive. So let's first expand the summation. Okay, it is x1 plus. Whenever you have such question, always make sure that you expand it so that all the terms are visible. Okay, and so on. And it will go till 1 by x. How much? Upper limit is 2024 minus 2025, right? But since all of these are variable terms and this is pretty much a variable itself, so let's pull it this side. So it will become minus x 2025. Now, the first thought that comes to any person's mind who is used to inequality is rather he'll go for AMGM. But AMGM will complicate things here, right? AMGM inequality. So what we can rather do is use Cauchy scores. And because I know this lemma, that is why this question is a bit easy for me. But it will generally help you in a lot of problems, right? So what T2's lemma states is T2's lemma, or you can say some say it as Cauchy angel. I don't know if it is angel or angel with an E. I don't remember it correctly, but as far as the lemma is concerned, what it says is summation ai square by bi is greater than equal to summation ai square, or rather summation ai whole square by summation bi. Okay, when is this valid? Ai should be positive and bi should be also positive. Okay, so if you want to apply Cauchy scores, then for applying Cauchy scores, just move it here. Okay, and I can clearly see that this may not be positive, the condition on AI, because the following proof will clear it up. See, so if you move it on this side, only BI needs to be positive. You'll understand in a minute. Okay, so this is something that we need to prove before moving forward. Okay, so here I'll use Cauchy Schwartz. So I'm using Cauchy Schwartz in this manner. I'll take these terms, okay, root b1 square plus. So therefore, for this to be valid, the bi should be positive, right? Greater than equal to 0. And it should be obviously not even equal to 0. If any of the bi is equal to 0, then the term will tend to infinity. But nonetheless, quality still satisfies. Okay, so these are the b terms, right? Up to say bn, right? And the second one is a1 by root b1 whole square, a2 by root b2 whole square, plus dot 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 bracket an by root bn whole square. Okay, so this is summation of squares multiplied together, so this should be greater than equal to summation of product. This is ai by a, or rather I'll keep it as a1 by root b1 into root b1. This is a very, very beautiful theorem. It will help you in many of the tricky Olympiad problems, right? An root bn divided by root bn whole square. Okay, so what do we have here? This is summation ai whole square, right? And on this side you have summation bi into summation ai whole square upon bi. Okay, see, you're able to get it. Let's move to the question, right? The next step is just bringing it down. Let me just finish it here, and the proof is completed, right? Okay, so if we want to use this inequality, then we'll simply put it in this manner: x1 minus x2025 plus. Now observe, x1 minus x2, x2 minus x3, dot dot dot, x2024 minus x2025. What does this become? it simply becomes, if you apply this T2's lemma here, so how many terms you have? This is x1, so this is the first term, x2, second term, x2024, so this is 2024 term, right? So you will have 2024, all are ones, and I goes from 1 to this. So this is top square plus all of the bottom terms. You can see that when you add the bottom terms, these will cancel out, right? And you will be left with this thing is greater than equal to x1 minus x2025. Okay, you can see that only the first term and the last term will remain. Rest all will cancel in a pair, right? This will go with this will go with this, and this will also go. So this thing is greater than equal to this term plus x1 minus x2025. Now see how beautifully you can apply AMGM here. Okay, so these are now two nice terms, and these terms, if I put it here, both of them together, so this will be greater than 2 into summation 2024 I equals to 1 1, and the square will vanish, right? This is 1 added 2024 times, which is 2024. Okay, so what I'm finally getting from here is that the one that we started with was this term, this whole expression, which becomes x1 minus x2025 plus summation format 1 over xk minus xk plus 1. K goes from 1 to infinity, 2024. Okay, so this is I'm getting greater than equal to 2024. And if you scroll to the question, then we'll get it as 2a, right? So a is what? So we can say that a has to be what? A is equal to 2024. Okay, I hope you like this question, Anna, because it was a breakthrough type of question for me when I was a kid. This Cauchy angel is so good of an inequality that one cannot ignore it if preparing for Olympiads. Okay, I hope you enjoyed the video. Do like, share, and subscribe. Thank you for watching. Bye.